Namaste learners. In last lecture, I was explained electric field due to electric dipole. Now, today I am going to explain electric potential due to electric dipole. And this is a scalar quantity, as you know. Just you find the 2-point charge system and calculate one by one, and just adding these 2 points and you will get the derivation of our requirement. And for this purpose I consider a electric dipole, and here is minus q charge, here is plus q charge, a small charge separated a small distance 2a, and this is distance r1 from the point A to P, and P is a point where we want to find the electric potential, and this distance is at R from the midpoint O, and this is R1. This point is R1, from A to P is R1. This is the R1 and this is the R2. Very simple. And Vp is electric potential. Electric potential at point P. At point P, electric potential at point P, this becomes Va plus Vb. And Va is what? Va is Kq by R1, and minus K minus Q by R2. It becomes Kq by 1 by R1 minus 1 by R2. It is so simple. This is, and just I calculate the value of 1 by R1 and 1 by R2 and put this value in this equation, and we find the potential at point P. And for finding the value of 1 by R1, I am using here cosine law. Cosine law, as you learned in class 11. And this is distance AP, means if I consider triangle AOP, then R1 square is equal to R square plus A square minus 2RA and cos theta. And theta is the angle between R and A side. R and A side, this is the theta. Then this becomes R square, taken out common, then 1 plus A square by R square minus 2A cos theta by R. And here this term is a small, A is less than R and tends to 0, means A square by R square is also very too small, hence neglected. Okay, then this equation is R1 square is equal to R square 1 minus 2A cos theta by R. This, and if R1 is here is equal to R and 1 minus 2A cos theta by R to the power 1 by 2. And if you reciprocal of this equation is, then 1 minus 2 cos theta by R 1 minus 2. This is minus 1 2. And using binomial theorem, 1 by R1 is equal to 1 by R, 1 plus 2 and 2 is cancel out, 2A cos theta by R. Then this and this cancel out, then 1 by R equal to 1 by R1 plus A cos theta by R. This is the equation number 2. 1 by R2 is equal to 1 by R 1 minus A cos theta by R. Similarly, equation number 3. Here similarly, the triangle BOP, in triangle BOP, okay, BOP means R2 square. R2 square is equal to R2 is the third sides, and first is A and second is R, then R square plus A square minus 2RA cos 180 minus theta. This and this sides, the including angle is this, and this is 180 minus theta. That's why I am written here 180 minus theta, and this value becomes R square plus A square plus 2RA cos theta. This, and here is minus sign, okay, then it becomes plus, and if here is plus sign, then becomes minus, and that's why here written is 1 minus A cos theta by R. And no need to go further, just you understand it. And Vp is equal to, therefore Vp is equal to KQ and 1 plus A cos theta by R, A cos theta by R, this one is. And the second thing is again 1 by R and 1 minus A cos theta by R, and KQ by R is common out, and it becomes a 1 plus A cos theta by R, actually minus sign here, then here is minus sign, then minus 1 by R, 1 by R is common out, and then minus 1 or plus A cos theta by R, 1 is cancelled out, and then KQ by R square into 2A cos theta. Then Vp is equal to K 2QA, means you may also write here Q into 2A cos theta by R square. Vp is equal to 1 by 4 pi epsilon naught. Q2A means P cos theta by R square. This is very common equation, P cos theta by. If theta equal to 0 degree, means axial point. Actual point means, suppose minus sign is this, plus sign is this, okay, and you want to find here P, then the value becomes Vp is equal to 1 upon 4 pi epsilon naught and epsilon naught P by R cube, okay. And if theta is 90 degree, means just perpendicular to this, and this is called equatorial line. Equatorial line means theta equal to 90 degree, okay. I need a space. Theta is 90 degree, then theta equal to 90 degree, known as equatorial line, means this is, suppose this one is the plus charge, this one is minus charge, and you want to find, and this is called this line, at this line theta and then electric potential is always 0, means at this line is इक्विपोटेंशियल प्लेन भी कह सकते हैं इसको हम। इस लाइन पे कहीं भी पोटेंशियल आपका यहाँ निकालिएगा तब भी जीरो, यहाँ निकालिए तब भी जीरो, किसी भी पॉइंट पे each and every point, I am writing here each and every point at equatorial line electric potential is zero. One method is also you may use to find this equation. Just I do this again, another method. suppose this one and this one is, suppose this one and this one is dipole minus q plus q, and this is the midpoint, and you find just this is point A, here is also A. You want to find the electric potential somewhere this, and simply potential simply kq by this distance, this one A, this one P, then AP, and again minus sign, then minus sign, plus kq by BP, don't worry, kq by BP. If you want to take here plus sign, here minus sign, as you wish, problem. kq by AP minus kq by BP. The problem is how AP and BP is found. One method is cosine method. You go through the cosine method and find the value of 1 by R1 and 1 by T, putting the value of this and find the value of VP. But here is AP. For this purpose, you just extend this line, and draw a perpendicular line. You just escape to draw such type of equation. This is the A, and as you know, this is the theta. Then the perpendicular distance, this is the perpendicular distance, this one is the perpendicular distance, and here is also perpendicular distance. Which one? This one is perpendicular distance. Okay, perpendicular distance. This one is perpendicular, this one is perpendicular. Okay, then the value is, suppose the name is here M, here is N or M, or this is the O. Then the value of this one is R from OP equal to R. Clear? OP equal to R. And this distance is, if theta, this one is theta, this one is also theta, and in this 90 is hypotenuse, this is the hypotenuse. Then as you know, cos theta is equal to base by hypotenuse. Base is this OM, and hypotenuse is A. Then OM equal to A cos theta. Okay, and OM equal to A cos theta. Similarly, ON is equal to also A cos theta. Similarly, ON is equal to A cos theta, OM is also A cos theta. And the angle is very small. Theta is very small, as you know, because it is electric dipole, and electric dipole has very a small distance between two charges. Then angle is also small. If angle is small, then we can approximate the value. And AP is equal to AP is near about this distance. This is the AP. There is two distance, AP, and this one is the BP. This one is the BP and this one is the AP. AP here to here, and BP is here to here. And you just consider R1 and R2 also as in previous method. And this is the construction. Draw a perpendicular line. Construction is here. You may write construction. You may write what? BM and AN. Draw BM and AN perpendicular to OP. Just perpendicular to OP. And our requirement is AP. Then this AP is suppose this is triangle, and suppose this one is the triangle. Then AP is near about PN. Then AP is approximate equal to PN. Then AP approximate equal to PN, and PN is equal to OP OP minus ON. OP minus ON. OP is R minus A cos theta. Okay, and similarly BP means which distance? BP is this distance, and this distance is approximate equal to PM MP something, and this PM is equal to OP plus ON. OP plus ON, and this is equal to OP is R and OM is A cos theta. This is A cos theta. And put the value of VP. VP is equal to KQ by AP and by minus KQ by VP. KQ is common out. AP is approximate equal to 1 by R minus A cos theta and minus 1 by VP is R plus A cos theta. And this becomes KQ, and you get LCM R minus A cos theta and R plus A cos theta. This, and R plus A cos theta is here, minus R plus A cos theta, and R are cancel out. R and R cancel out. Then VP is equal to KQ 2A cos theta, KQ 2A cos theta upon R square plus A square cos square theta. This is minus sign, cos square theta. 2QA, Q into 2A cos theta upon R square minus A square cos square theta. This one VP equal to 1 by 4 pi epsilon naught. This one is P. Which one P? This one is P. This one is P. Then it becomes P cos theta by P cos theta by R square. Because A is tends to 0. A is less than R. And this equation is for few. And theta is 0 degree. Theta is 0 degree, then VP equal to 1 by 4 pi epsilon naught P by R square. Here one thing is, electric potential due to dipole is inversely proportional to R square. This is the new thing. You must remember it. For point charge, it is inversely proportional to R, and here it is inversely proportional to R square. As like electric field due to point is inversely proportional to R square, but due to dipole it is inversely proportional to R cube. ओके, तो आप लोग को ये समझ में आया होगा, दो मेथड से मैंने इसको किया. अब हम आते हैं इस पे इलेक्ट्रिक फील्ड लाइंस. नाउ द टॉपिक इज इलेक्ट्रिक फील्ड लाइंस. इलेक्ट्रिक फील्ड लाइंस इज ए पाथ, either a straight line path or curved line path, at which a vanishingly small positive charge can move if it is free to do so. अगर हम किसी पॉजिटिव चार्ज में उसका वैल्यू बहुत छोटा हो, अगर जिस पाथ पर वो फ्रीली मूव करे, उस पाथ को ही हम लोग इलेक्ट्रिक फील्ड लाइंस कहा गया. Electric field lines is not, suppose that कि 10 कूलम चार्ज है, तो इस 10 कूलम चार्ज में कितना लाइंस निकलेगा, ये तो नहीं पता कितना लाइंस निकलेगा. तो ये एक रिलेटिव स्टडी है. इलेक्ट्रिक फील्ड लाइंस से हम ये बताने का प्रयास करते हैं, एक मेथड है समझाने का कि हम चार्ज को कैसे हम उसको इंडिकेट कर रहे हैं, किसका स्ट्रेंथ ज्यादा है, किस चार्ज ज्यादा है. अगर किसी के पास 4 लाइंस दिखाए तो ये 10 कूलम का हुआ, तो किसी का अगर हम 8 लाइंस दिखा दे रेडियली आउटवर्ड, इस तरह से 2 3 4 5 6 7 8, और पूछ दे कि यहाँ पर चार्ज का वैल्यू क्या. रिलेटिव स्टडी है. अगर इसका 4 लाइन बनाए 10 कूलम में, तो 8 लाइन कितना कूलम में हो जाएगा. तो श्योर यू फाइंड आंसर 20 coulomb charge. Then it is the relative things. If a charge has 4 lines for 10 coulomb, then 8 lines for 20 coulomb. And as you know, if 10 lines is there, then what? 2, 3, 4, 5, 6, 7, 8, 3, 6 to 8, 9 and 10. Then what is the value? You can decide it. Okay. So first of all, electric field lines is a path on which a vanishingly small positive charge can move if it is free to do so. अगर ऐसा करने के लिए छोड़ दे, कोई रुकावट पैदा ना करे, तो जिस पाथ पे वो जाएगा उस पाथ को इलेक्ट्रिक फील्ड लाइंस कहा। वह स्ट्रेट लाइन भी हो सकता है और कर्व लाइन भी हो सकता है, दोनों हो सकता है। इलेक्ट्रिक फील्ड लाइंस जनरली पॉजिटिव चार्ज से इमिट करता है, पॉजिटिव चार्ज से इमिट करता है और निगेटिव चार्ज में इंटर करता है, ये अंदर की ओर आएगा। पॉजिटिव चार्ज से इमिट करता है और नेगेटिव चार्ज में अंदर की ओर आएगा। अब इट इज ए क्लोज पाथ। अब क्लोज पाथ कैसे? तो अगर हम प्लस चार्ज ले लें, एक माइनस चार्ज ले लें, सपोज दैट वन इज कंसिडर्ड ए प्लस चार्ज एंड अदर इज कंसिडर्ड ए माइनस चार्ज, देन the lines goes from plus to minus. This one is this and this one is this, and this is the in this direction, sorry, in inner direction, this somewhere bending here because must be perpendicular lines bending here, and this is outward close. This is open path, sorry, this is open path because just think about this. From this line, opposite direction, this is the open, and magnet. One is the north pole, other is the south pole. North pole and another is south pole. It becomes closed loop. This one is closed loop. Here is also just like closed loop. Forms a closed loop. And here it breaks. This breaks. And that's why it is open path and here is closed path. In magnet it is a closed path and electric field open path. Now tangent on electric field lines gives direction of electric field. Yes, tangent means if electric field is curved, suppose this is the electric field, then tangent gives the direction of electric field. It is so his tangent on electric field lines gives the direction. And one more thing is here, two field lines never cross to each other. ऐसा कुछ समझाने के लिए हम लोग कॉन्ट्रडिक्शन मानते हैं कि अगर क्रॉस कर गया तो मान लिया जाए, सपोज two lines are crossed to each other, then just you studied here, the tangent gives the electric field direction. At a single point, two direction is not possible, and that's why they are not crossed to each other. Little more thing about the electric field lines. One thing is attracted longitudinally and repelled laterally, and this gives the attraction and repulsion force. How? I explain. Plus charge, and this is the minus charge, and longitudinal length this shows the attraction force. This is the attraction, but plus sign or minus sign many times the diagram of magnetic field lines asked in examination for the single charge, for the double charge, then you may also understand here. This is the electric charge, then suppose that this one, and this is laterally repelled. This is the laterally repelled. This one. This is the laterally repelled. Means the two lines are repelled. This is the laterally repelled, and this is the longitudinally attract. This is the longitudinal attraction, means attraction force, shows the attraction force, and this is the laterally repel, this is the repulsion force. Prove the repulsion force. This is the repulsion force, and this is the attraction force. And this is also repulsion, minus minus charge. Then you may draw minus charge and minus charge, then also repel to each other. Similarly, this direction is just reverse. Okay, this is the line. Now at this line, potential is 0. Here also potential is 0. Is this or at this line? Electric potential is 0. And you may call the equipotential side. And one thing also, electric field line due to longitudinal charge rod. This is also parallel and almost constant near the charge rod. This is the point due to the point charge radially outward. This is radially outward. This is called radially outward. Just think radially outward. You may correct the spelling also. Minus charge, minus q, then radially inward. This is the radially inward. This is radially inward in isolated charge, radially outward isolated charge. And if two charge is plus and minus, then electric field lines as like this. And for plus charge, electric field lines repulsion. And for two negative charge, also electric field lines repulsive. Okay, this is about the structure of electric field lines. One thing is more for the electric field lines. When two charges are separated at a distance r, and at midpoint we want to find the electric field, then this is the plus charge, then this electric field about this and this, both are equal and opposite, and then electric field is 0. The at point where electric field is 0 called neutral point. The field is 0 at the middle point N of the join of two charges called neutral point. This is called neutral point. And this type of question is asked many times in competition also. Suppose that a 10 coulomb charge and here is the 5 coulomb charge, and questioner asked where is the electric field 0, then just you consider a point from anywhere or put the value of 1, then this is plus charge, this is plus charge, then electric field in this direction, and another case due to this electric field in this direction, but both are in different magnitude. And suppose this one is the distance x and this one is the r minus x, because the distance between these two is r. According to the question, according to situation, net electric field is 0. It means what? E1 equal to E2. Okay, then the value is kq by x square and equal to kq by r minus x square. You find the q1 and q2. This one is, and you find the required value as asked in question paper. And suppose the q1 and q2 is a different charge. Minus q1, here is minus q1 and another is the plus q2. Then where is the electric field is 0? Suppose you put here plus unit charge, then this becomes attraction force, this becomes attraction force, both are in same direction, and then in between two charges it is not possible. Anywhere it is not possible. And in this point, just beside at this point that this is the attraction force or this is repulsion force, and here may be positive, may be 0, and depends upon the magnitude. Here also possible, depends upon the magnitude. Then first of all, you want to find the neutral point or electric field 0 at a point, then you put a plus charge and think the both electric field in same direction or in opposite direction. If in opposite direction, then neutral point may becomes, otherwise it is not. And there are so many questions are solved by this concept only, and this is called the neutral. Once again, two important things: solid angle and area vector. It is required for the Gauss's theorem as well as electric flux, and that's why I am discussing here. Just like solid angle. Solid angle, suppose that the angle, plane angle. First of all, I want to discuss plane angle. Plane angle. Then plane angle, as you know, this is the ray, point here, and this is the angle. And this angle is angle equal to arc by radius. Angle equal to arc upon radius, as you know very well. Then theta equal to arc is this. Suppose that L1, then R1 is radius, then theta equal to L1 by R1. Okay, no problem. Arc is L1, radius is L1, this one is L1, this one is the L1. And if arc is L2, then angle is constant, L2 by R2, and the distance is this, R2. Similarly, if you consider this angle here, this one is, this is the point O, and this is the solid angle, this is the angle, three-dimensional thing, you just imagine three-dimensional thing. Then this distance is O to R, this is R1, this distance is R2, this distance is R3, and angle is called delta omega. This is solid angle, delta omega, solid angle, representation of solid angle. Okay, then del omega is equal to a small area by R1 square. This may be also ds1. Delta omega is equal to ds2 by R2. This one is called solid angle. Then what you observe? Nothing. I don't. Just I consider a fruits, and this is the cone. This is the cone. Just you see, I like this. This is the cone, and this is the fruit in spherical shape. And when you put this cone on this surface, as like this, then this point, from this point to this distance has some distance, and this is called R1. This is called R1. And the area covered by this, as like this, the area covered by this cone on the fruit, just like you measured by the graph paper. You measured by the graph paper. This area. Then this area is ds. This area is, how you can find this one? By the graph paper or other method. Just find the area. Graph paper actually two-dimensional thing, but here is three-dimensional. Then you use to find the area for different method, as you learned in class 11. Then this is the area, and this area is ds. ds1, ds2. If cone is small, then area is small, and if cone is suppose that this, then area is covered less, and for this area covered more, then area is less, then R1 is less. If area is more, suppose that ds2, this one is the ds2, this one is the ds2, this one is the ds3, ds1, then area covered by the cone, as like this cone, then area is this. Suppose that this area, and the distance from here to here, point here to here. And if you cut this one, then area becomes less and distance becomes less, but angle is same, as like a plane angle also. Okay, one more thing is also here. Area vector. Area is a scalar quantity. Area is a scalar quantity. No doubt. A scalar quantity. No confusion about this. Area is a scalar quantity. But area of, suppose that this is a sphere, and you just draw this one and find the value of ds. This one is ds. A small area. Then it becomes vector quantity. It becomes a small area. This one is the perpendicular. That's why it is written as dsn cap. N cap means normal. Normal means 90 degree. And everywhere there are small area is considered, and integrating these all and find the total area of this. Suppose that I am also here using a spherical fruits is like this. This is the and toothpick. One is the toothpick, another toothpick for finding the value of this one is. Suppose this is the sphere and this is the area. This is the perpendicular area. This one is center outward. From the outward, this is the perpendicular. And how it is perpendicular? Then at a single point, put a plane surface as like a plane surface. Then this is the tangent, perpendicular to the tangent. You also cut the fruit from this end, Then this becomes a spherical shape. This becomes a spherical shape. Suppose that this and this is the area vector. This is the area vector. Area vector is always normal to the surface, and here is also normal to the surface, and that's why a small area considered as a vector quantity, but large area is considered as a scalar quantity. Very small, a small area is considered as vector quantity. Just like a small angle, very small angle and displacement, angular displacement considered as a vector quantity, or big angle is considered as a scalar quantity, because the cross product or some other rules is not followed by the bigger area but followed by the smaller area. And these two things helps you to understand the electric flux and Gauss's theorem. I will discuss later. The time for potential surface. EQ means same, potential means potential, as you know. Equipotential means any surface at which potential is same, and electric potential is same. Potential is same, called equipotential surface. At any surface, equipotential surface, at which surface is, means property at equipotential surface, potential surface, change in potential is 0 and work done is also 0. Means what? When you bring a charge from one point to other point on equipotential surface, then work done becomes 0. Means Q into dW, W equal to what? This, and it becomes 0 because delta V is 0. Then work done on moving charge, work done due to moving charge from one point to other on equipotential surface, and work done is 0. And third is electric field lines always perpendicular to equipotential surface. This means if you draw equipotential surface for individual charge, means for a plus charge, individual isolated plus charge, then the equipotential surface is like this. Equipotential surface like this, always this line. Concentric sphere here, this line. This is the equipotential surface, and electric field lines is perpendicular to this. Perpendicular. This is the perpendicular direction, as like this. This is the dotted line shows the equipotential surface. This is the equipotential surface, whereas this indicates, blue line indicates electric field lines, which is perpendicular radially outward direction. And for the similarly negative charge, suppose this is the negative charge, then equipotential surface is as like this, symmetrical. This is the symmetrical lines, and this is the equipotential surface, and the electric field in what direction? This is the In what direction? In what direction? This one is the electric. And there so many times it is asked by the examiner, what is the equipotential surface due to positive charge, due to negative charge, and for the system of charge also. Now I am going to draw for the system of charge. Just one is plus charge and other is minus charge. Suppose that this plus charge and this is the minus charge. If you consider plus charge, then it is more difficult than previous, and that's why I am looking here and there. This is this one as like this, as like this. The distance towards this end is increasing. This one is increasing. And the drawing is too difficult, that's why I am taking time. And this is also as like here end is near and then further far and then more far, this. And electric field lines perpendicular, no doubt, perpendicular to each other, and this one is the perpendicular to this one is the this, and this is the this, okay, and this is the outward. Always bend like a structure because this is the perpendicular to the surface, perpendicular to the surface. Don't draw a straight line. This one is also, here is also, here is also. So many more. You can draw more. But one thing is very carefully draw. This and this is denser and this is non-uniform. This is denser and this is non-uniform. This is the equipotential surface. This one is the equipotential surface. Red line, equipotential surface. And this is the electric field lines. Okay? Draw properly. For two positive charge, this is positive charge and this is the positive charge. For two positive charge, equipotential surface is just like here is dense in right side, opposite to the above. This is the right side. Right side is lesser. This is the left side. Left side is denser and right side is lesser. Similarly here also, here is lesser and at this end is denser. At this end is denser. You draw carefully, otherwise it becomes wrong. And this is outward, this one, suppose that this one is electric field, blue lines, electric field lines, black color, positive charge, and this one is the equipotential surface. Equipotential surface. This one, and just you draw more lines as you mentioned in your book. You draw more lines, but carefully. This is the as like this. This combine to these two, and this becomes or more and more, and final equipotential is combined as like this system. And if you draw such like diagram, then you will get full marks. Otherwise, marks should be deducted. And your complaint is, I am drawing very good, but teachers and does not give the marks. Okay, don't worry. It is the process of learning and teaching process. And one more thing, equipotential for uniform electric field. Uniform electric field. Electric potential due to uniform electric field. Then means a source charge is placed so far. बहुत दूर रखा हुआ है कोई सोर्स चार्ज. then the equipotential is the parallel and at equal distance. One thing is more, at equal distance. Okay, then perpendicular lines is the electric field. Okay, equal distance. If one is also you want to, then equal at equal distance, equipotential surface as like a pages of books, as like a page of books. This one is the page of, this one is the, each page equipotential surface. Each page of book is a equipotential surface, and electric field lines is perpendicular to this book. Same. Okay, this is the book and each page is equipotential surface, and this is the electric field lines perpendicular to the surface, and this is the equipotential surface. Okay, one more thing, relation between electric field and potential gradient. Charge is Q, and at point P, which is distance at R, and another point is Q, which is at distance R minus dr, and suppose a small charge carried from P to Q, then a small work done is required. A small work done is required to move, required to bring a charge Q naught, this one is. Then work done is charged into potential difference. At this point, potential is more, means V plus dV, and this point is V. Near the source charge, the potential is greater, and farther the source charge, this is the source charge, farther the source charge, it is lesser, and the potential difference is V plus dV minus V, dV cancel, that remains dV, and this is the Q naught dV. This is the work done, and this is the work done, and we want to find dW as F vector dot dl vector, and as you know, it is the Q naught E, but in opposite direction, F equal to minus Q naught E, as you know, because it is we are doing work against the electric field, and that's why here is minus Q naught E or into a dot dl, and E vector is in this direction and dl is in this direction. That's why I consider theta is equal to 180 degree. Then minus Q naught E dl cos 180 degree, and this becomes dW is equal to Q naught E dl. Q naught E dl. dW is equal to Q naught E dl. And putting this value in equation 1, we get dW is equal to Q naught dV, and dW is Q naught, and one thing is more here, dl is equal to minus dr. Why? dl is considered as minus dr. Why? Because dl is in direction of decreasing r. Here is dl is in this direction and r is decreasing, and that's why I consider dl equal to minus dr, simply minus dr, and that's why here I am writing Q naught E into minus dr is equal to Q naught dV. Q naught cancel, therefore electric field equal to minus dV by dr. You may write in vector form ER in vector form dV by dr. And potential gradient, this is called dV by dr is potential gradient. And this is always decreasing in electric field. If in the electric field in this direction, then higher potential is at this point. Higher potential at this point means plus means higher potential, and here is the lower potential. Or consider electrons in this field. Consider electron. Suppose this is the electric field. Consider then force is equal to, generally written as u e vector, and this becomes F equal to minus e vector, means the force on electron in this direction means lower potential to higher potential. That is why electrons move from lower potential to higher potential. Then write electron moves from lower to higher potential. Lower to higher potential. This is very important to explain the current electricity chapter. Okay. The next topic is electric potential energy of electric dipole. Electric potential energy of electric dipole. Electric dipole. Just I consider electric field. This is the electric field, and this one is the electric field, and one third line I will draw here. And one is here, this one is here, plus electric dipole, minus charge, plus charge, and the distance between this is 2a. Okay, and the direction of electric dipole moment is in this direction, and electric field is in this direction. That is why the angle between electric field, this is the electric field, and this is the P, and the angle between these are the theta, and this is the construction perpendicular. If this is theta, this is also theta, this is also theta, and this distance is 2a from here to here, 2a, and this is 2a sine theta. This distance is 2a sine theta. Then dw is a small work done to rotate an electric dipole against torque acted. When torque acted means tau into d theta. Just you know the work done is equal to force and displacement in rotational motion. Work done is equal to torque, means rotational force and angular displacement. That's why I am writing here dw equal to tau theta. Means dw is equal to tau means P is sine theta, and this is the theta, d theta. And total work done means P is sine theta d theta from theta 1 to theta 2. Where is theta 1? Theta 2. Just I draw. Suppose the dipole in first situation is this condition, means this angle is theta 1, and now you twisted from here to here some different angle. This becomes a theta 2. Theta 1 to theta, just twist. Then work done is required, and this work done is P is constant, a minus cos theta, and this is theta 1 to theta. The integration of sine theta and theta is minus cos theta. That's why I am using here. And this work done converts in potential energy Pe, and for removing the sign, just reverse the order. Okay, then U equal to Pe cos theta 1 minus cos theta 2. This is the simple relation between this. And now, if theta 1 is considered as 90 degree, theta 1 considered at 90 degree, and theta 2 is theta, then equation becomes Pe cos 90 minus cos theta, and this becomes U equal to minus Pe cos theta, and this is in vector form, U equal to minus P vector dot E vector. This is very important relation. This is very important. Minus P or minus P. If you want to take only magnitude, then minus q cos theta, and with the direction, with the vector form, then you may use dot product. This is the dot product, hence it is a slug quantity. Two more things, a stable equilibrium and unstable equilibrium. A stable equilibrium. A stable equilibrium means potential energy should be minimum. Potential energy should be minimum. And for minimum potential energy, this should be minus Pe. And how it becomes? Then theta is equal to 0 degree. Then U equal to minus Pe cos 0 degree. Then it becomes minus Pe. Potential energy is minimum. When electric field and dipole both are in same direction, then it is a stable equilibrium. How? Because potential energy, this value is minimum. For minimum value, a dipole is in a stable equilibrium. And the second situation is potential energy should be maximum. Should be maximum means unstable equilibrium. Unstable equilibrium means potential energy should be maximum. For maximum potential energy, U becomes Pe. It is possible when theta equal to x of 80 degree. Means electric field and electric dipole both are in opposite direction. Electric field and electric dipole both are in opposite direction, and that's why it is 180 degree and potential energy becomes maximum. And this is all about electric dipole. I finished today and become happy, and you stay happy and stay at home and learn more and do homework and do exercise of NCRT as well as C Burma and also MCAT. Okay, thank you.